Hello everyone. Welcome to the Syed's School. Today, we will learn about operating routers and static routes configuration. Why do we need routers when we have switches? Switches works in the same network unless the switch is a layer 3 switch. If we have to communicate with an IP address of the other network or subnet ID, we need to use the router. Routers are called layer 3 devices as they use IP address to route the packets between different networks, whereas the switches uses the MAC addresses to forward the packets. Ports on a router. Cisco routers has various types of ports like serial ports, fast Ethernet ports, gigabit Ethernet ports, SFP ports, RJ45 auxiliary ports, RJ45 console ports. We use WAN links provided by the service provider in most of the cases. So, we need to use the appropriate port, SFP or RJ45, based on the standards of the WAN link provided. Every port on a router need to have an IP address unlike switches. How router learns routes. Static routes, these are the routes we add manually in a router. These routes are very useful in small networks and as a redundant route link. Dynamic routes are like self-updating maps for network traffic. They allow routers to automatically learn about new networks and choose the best path for data to travel, adapting to changes in the network. We need to configure dynamic routing protocols on routers for dynamic routing. Dynamic routes are useful in larger networks and when the link fails or topology change. Let's learn routing using this topology. We use 3 networks here as shown. 192.168.1.0, 2.0 and 3.0. We use 2 routers to connect 3 networks. Router 1 F1/0 port is connected to network 1. Router 1 and 2 gigabit ports are connected to each other and are in network 2. Router 2 F2/0 is connected to network 3. Let's configure router ports and add static routes so that host 1 can communicate to host 4.
Now we need to configure the router interfaces, add static routes so that each device in this network is able to ping the other device. Let's go to the router 1. Let's go to the enable mode. Let's see the running configuration of this router. We see that the interfaces are in shutdown state by default unlike the switches. Let's go to the configuration mode and configure the fast Ethernet 1/0 connected to network 1 and the gigabit Ethernet 0/0 connected to the router 2. Let's go to the interface configuration mode and set the IP address of this port with the subnet mask. We have assigned the IP address and will not execute no shutdown command to get this interface in up state. Please note that this F1/0 interface is in the network 1 same as host 1. Now, let's configure G0/0 connected to router 2. Please note that the G0/0 is in network 2. Now, let's try to ping F1/0 and G0/0 from host 1. Please remember that they are in different networks. Let's assign host 1 an IP address of network 1. Let's ping F1/0 address. We get a reply as they are in network 1. Let's ping G0/0 which is in network 2. We see no reply as this is other network. Host 1 does not know where to forward the other network packets. What to do now? Let's assign a default gateway to host 1 so that it always forward the other network packets to the default gateway and default gateway do the rest. Default gateway will be the router port address in the same network. Here it is F1/0 address which is 192.168.1.4. Let's assign host 1 default gateway using this command. Now, host 1 knows where to forward other network packets. Let's try to ping router 1 G0/0 interface now. We get a reply now, which means that host 1 can reach till router 1. But how router learns that the network 1 is connected to it? If a router port is assigned an IP address of a network, then it add the route of that network via that port. This learning is known as connected routes learning. Now, let's go to the router 2 and assign IP address to its ports. Let's configure G0 by 0 of router 2 connected to the router 1. This port is in network 2. Now, let's go to the router 1 and check its routing table. Show IP route is the command. We can see L, C, and S here. We also see the dynamic protocols here which we will learn later. Let's learn static routing now. C is the directly connected network or subnet. In this case it is network 1 via F1 by 0. We also see the directly connected network 2 via G0 by 0. We see L here which is local host and just one IP address of a port with /32 prefix. In this case it is F1/0 which is .4. Similarly, G0/0 local host. Now, can we ping router 2 G0/0 using host 1? No, but why? Because host 1 will reach default gateway and router 1 knows how to reach router 2. But, router 2 just knows how to reach router 1 and not the network 1. So, if we ping someone, they should be able to reach us too, otherwise there will be no communication. Now, we need to tell the router 2 about network 1 by configuring static route so that router 2 could reach network 1. This is the command to configure static route. IP route network or subnet ID with mask and then the outgoing port to reach the network or the next router address. Now, ping the router 2 from host 1 and we will get the reply as the router 2 has a static route to reach host 1 network. Now, we can reach till router 2 or network 2. Can we reach network 3 or host 4? Let's add an IP address to the router 2 F2/0 interface which is connected to the network 3. Now, let's ping the router 2. F2/0 network 3 interface. It is unreachable as the router 1 does not know the route of network 3. So, let's tell the router 1 the way to the network 3 using static route command. This is the static route to reach network 3. Now, let's ping router 2 F2/0 port in network 3. We get a reply now as router 1 known the network 3 route. Let's switch to host 4 and assign it a network 3 IP address. We know that host 1 can reach host 4 as router 1 and router 2 has routes. However, if we ping host 4 from host 1, we get no reply. Why? The answer is host 4 does not have a default gateway and so, it does not forward the packets to the router. Let's add the default gateway to the host 4 which is the router 2 network 3 interface address. We can deduce that just reaching from host 1 to host 4 is not enough for communication. The reverse path is also important. This is how we troubleshoot. Now, we have added default gateway to the host 4 opening the path to reach the host 1. Now, they can communicate with each other. We see that host 1 can ping host 4 now and vice versa. Let's go to the router 1 now to check the static routes. We see that static route S here to the network 3 through the gigabit interface.
Static default route. Imagine an enterprise having 2 to 3 remote sites with just one WAN link connecting to the enterprise central site. Instead of adding routes per network, as we just have just one WAN port or one WAN physical link, we can add a default route so that the router knows to forward any packet with any network through that one link. Here is a command to add a default route in a router. Let's look at this topology with 2 remote sites and a central site. We configure default route at 2 remote sites. Remote routers forwards all the non-local packets to the central router and the central router takes care of further routing. Permanent static routes. Suppose we add a static route and the links are up in that route. After some time, if the links go down for some time, the routers remove the static route. Permanent routes helps in this case. These routes does not get removed even if the links are down for some time. Here is a command to add a permanent route in a router.